Good afternoon, everyone. My first shout out, it's not going to be a shout, don't worry. First shout out is a celebration that I still have my voice in these Arctic conditions that we're in today. Okay, we're working now. Thank you. My presentation today is called Clocking the Telco Cloud. It was a sneak preview yesterday for some of you who saw it, but it's probably going to go into a little bit more information today. So my name is Anand Ram. I look after business development at Calnex. We're a test and measurement company. We make testing systems. But really, my talk today is really to talk about our experience in talking to the telco and the data center community about an initiative that's growing in importance, which is the Telco Cloud. At Calnex, we've talked a little while, and so has this whole community at the Time Appliance project, about the need for timing, precision timing in data centers. So I call that clocking the cloud. So we've talked about it a lot. There's a lot of information available online from us, fundamentally about how delivering precision timing all the way to the servers and then up into the software can benefit a data center and can enhance what a data center can do more efficiently. But there is a new drive for that precision timing to data centers, and you've heard some of that, a flavor of that in some of the previous presentations. And that is effectively about running a telecoms network, and specifically a mobile network, on the data center infrastructure. And so we're going to talk about that a little bit today. But first of all, let's find out what we mean by the Telco Cloud. And depending on who you ask, you will get a different answer probably every time about what Telco Cloud means. But since you asked me, I'll give you my version of it. So Telco Cloud has been used for many years, the phrase Telco Cloud. And it's really about telecoms infrastructure being put on the cloud. In the early days, there's a lot of work in the last 5-7 years of disaggregating platforms. So in fact, the telecoms community has been working for a while on disaggregating their platforms from vendor-specific platforms that was the norm in the telecoms world to simply disaggregating software running on off-the-shelf or white box or bare metal hardware. So that's been happening for a while. We're disaggregating the hardware and the software, and there's been deployments of many of these platforms around the world. What's been building in momentum in terms of the telecoms world is really a lot of the stuff that we're used to in the data center world. I've listed some here: SDN, containers, microservices, automation, orchestration, stuff that is the norm in data centers was not the norm in telecoms. And stuff like that, all the clever stuff that makes the network run more flexibly and more efficiently, there's a lot of work going on in terms of doing data center type technology in telecoms type networks. So again, that's not so much relevant to us because that's not about timing. What is relevant to this project, the Timing Appliance project, is really about deploying mobile network functions in the cloud. And we'll see some examples of what we mean by that. This really started with the mobile core. Now, the mobile core is simply data. It's management and information data. So the core of mobile networks for many years, again, has been moving to the cloud. Most cases with telecoms operators, it's been private cloud. So for example, AT&T would build their own cloud effectively, which just means servers, and the servers contain the information and the data for the mobile core. So that's been happening for a while. So the mobile core is the first thing that moved to the cloud, you could say. And increasingly, that's moving from private cloud to public cloud as well. So that's happening as we speak. But what is also happening is things like transport, switching, and radio functions moving from, as I say, dedicated telecoms hardware infrastructure into cloud or data center type infrastructure. And these are the areas, these are the functions that really have critical timing requirements. And that's what we're here to talk about. But first of all, let's also ask why does the concept of telco cloud exist? Why are mobile operators excited and interested in moving their functions into the data center world? Well, the primary driver is really flexibility. Again, for those of you who have knowledge of the telco or telecoms world and the telecoms networks and the data center world, data center networks, Obviously, the data center infrastructure has been built to deliver flexible services fast, right? You can spin up a new service, you can spin up bandwidth, you can spin up applications very, very quickly. That was not the case in the telecoms networks. To spin up a new service in the telecoms world was a very slow, painful process. So that flexibility is hugely important, as the mobile networks now want to try and become more flexible so they can actually monetize their service better. So the flexibility of the cloud infrastructure really interested telecoms carriers. But then there's also the economies of scale. That's another huge factor. Very, very quickly, infrastructure for data centers overtook infrastructures for telecoms. And that simply delivers scale. So in order to, if you're going to buy equipment that's normally used in a data center, it's a lot cheaper than buying equipment that's going to be used in telecoms infrastructure. So again, the economy or the cost factor was a big driver. However, what many companies have found in this migration journey, the AT&Ts of the world are finding it difficult to overnight become a Google or a Meta. The technology, the expertise, and the systems in place are very, very different in a telecoms network versus a hyperscaler. And vice versa as well. You know, the data center community has developed an infrastructure. For example, take precision timing. It's not there from the start, whereas in a telecoms network, precision timing was there from the start. So in both directions, these are two different worlds trying to come together. And one of the biggest deployments, or at least the ones that have been shouted about the most of the Telco Cloud, is one here in the US, which is the Dish Network, which is slated to be launched soon. It's been slated to be launched soon for a while, but it's coming. And this is a new carrier in the US that has really built its entire network on a hyperscaler infrastructure. So they've announced that they're using AWS for a big part of their network. And fundamentally, what you see here is a diagram there was an interpretation of all their announcements at Dish. And this is showing the radio network or mobile network functions running on AWS infrastructure. So the AWS region data centers house the cores and a lot of the mobile network functions. And then you'll see the local zones, the AWS local zones housing the CU or the centralized units for the 5G network. And then the outposts towards the outside of the network housing the DU or the distributed units. So these are telecoms, mobile radio network functions running on the cloud, on the public cloud in many cases. So that's great. We're starting to build a network on a data center infrastructure, a mobile network on a data center infrastructure. All going very well. But there are fundamental requirements for synchronization. And again, if you've sat through the previous presentation, you've seen this 4 or 5 times now. I won't go into it again and again, but fundamentally, mobile networks need synchronization in order to work. And the key number here is the 1.5 microseconds you've heard of going to the radio unit, and an indication of about 3 to 5 microseconds needed to synchronize the central clock to the distributed unit. So what do these requirements mean in the world of the data center? Well, very simply, what it means is that we need a centralized clock. We need to deliver the accuracy from that centralized clock to the DU and the RU. And if the DU and the RU are running on Amazon servers, that's where we need the accuracy. And in general, the data center infrastructure was not initially built to deliver a microsecond to a piece of server that's sitting out remotely. But this is what needs to happen in order for a data center or hyperscaler to host a mobile network. The good news is all of the formulas for the mobile network are ready. Initial mobile networks, and in fact today, the majority of today's mobile networks are already built, and they were built using these formulas. It's the same formulas, the same methodologies. And we start with, and that's one of the roles of this project here, the Time Appliance project, we start with defining a methodology of how you're going to deploy timing. So the OCP has a data center profile, and that was worked on as the initial work of the Time Appliance project here. And the profile just says, here's how you deploy timing across a data center infrastructure. So we need standards and recommendations, and of course, all of the test methodologies, support, and resources. And as I said, the good news is all of this is ready and pretty much good to go. So, so what do I mean by that? Again, don't worry about the scale of this slide. The ITUT is the International Telecoms Union. They took their requirements from 3GPP, which is the mobile radio industry. So 3GPP came up with specifications for the mobile network. That got translated into requirements for the transport network by the ITU. And that's exactly the requirements we need to follow for when we're deploying timing across a data center infrastructure. So all of these recommendations, you can see that there's a little bit of work to be finished, but it's predominantly done, and it's been done for 5G as well. So we had the recommendations. We fine-tuned them to kind of apply them to the data center world, and that's what the things like the data center profiles will do. And then companies like us, we have a vast library of information and resource that you can go to. So we call it G.What. The name G.What is because all of the ITU standards that you see here are always G. something else. There's G. a number. So our information portal is called G.What. In here, you'll find all of the information about, well, how do I build a network from the timing server all the way down to the client? How do I deploy it? What performance does it need to meet? And so on and so forth. And again, just to summarize, we are seeing a trend in the industry where mobile network functions and the infrastructure are moving to the cloud. What do I mean by that? As I said, I mean that AT&T, T-Mobile, Verizon, China Mobile is taking its network and moving from what we call a telecoms switch network to a network that looks very much like the network you guys see in the data center. So we do need a host of new systems and software that need to perform to the telco specs. There is no source of timing, precise timing in many data centers. The racks and the servers and the top of rack switches and the spine and leaf switches and the server network interface cards, all of this stuff, none of that was originally designed to support these performance requirements, and they need to be upgraded or designed to support these requirements. And all of that needs to be verified, of course. But like I say, the good news is that the standards are in place, the ITUT recommendations are all in place and being established. There are some requirements of what we call ORAN, which is the Open RAN body. A few more of those need to be refined. And then we are having these discussions inside the OCP. So ultimately, you can make the OCP will become a point of reference for if a data center operator wants to run a mobile network in their facility. Okay, just a final reference, which is again available in the slides. We have information that, as Samad said, I lead the instrumentation and measurement workstream at the OCP. Our role eventually will be trying to get a lot of this methodology that we talked about put into this workstream. And also the ITUT standard resource that I saw earlier will give you information about all of the deployment recommendations and the test methodologies that you have to go through if you want to run a mobile network in a data center. Okay, thank you very much.
Any questions? Ariel.
Yeah, another
Ariel.
quick question. So if this is happening the way you described, how come there is nobody from AWS, Google, or Azure in the audience, and who's representing the needs?
So there's some flinches there, so I think there may be. That is the answer.
They're hiding.
But good point. Why isn't there more? But there is. You know, it is happening.
I don't mean it in a negative way. Outreach. Should we be reaching out to them and saying, "Hey, look at what we're doing"?
Absolutely. You know, I think we try and do that as a company because we try and put information out there saying it's happening. You know, but you're right. I think it's a good idea for people like the OCP to, you know, run a webinar that has this kind of content. But again, not disclosing any information, but I will tell you that we, as a test company, we are privileged because, you know, we're not trying to sell networks or systems, but we are talking to everybody you just mentioned about precision timing.
And that's a fair answer. If you tell me I understand what they need and I'm presenting that, I'm happy.
Okay, good. Yeah. Well, we're about 50% of the way there, yes, I would say. Thank you, though, for the question.
Good point. Okay.
Okay.
Looks
So go ahead. Sorry.
Just wondering, what will it take to upgrade an existing center architecture? I mean, your servers and Tor switches and everything has been designed, and I'm wondering if OCP can, like going forward, talk to a modularity where you can just swap it out and make it telco-centric. I'm just trying to kind of fathom the effort needed, or if you guys already figured it out, or something to that effect. I'm just trying to understand the deployment aspect of it.
Yeah, it's an interesting question. I mean, obviously, I talked about the OCP profile. Now, if you have nothing and you're building an infrastructure from scratch, great. Look at the profile, buy new stuff, build it. If everything's already in place, it's a very good question. How do you then upgrade? So the only answer I can give to that is, from what we've seen, everybody's doing something slightly different. It depends on. I mean, ultimately, it's the pull, right? If an AT&T comes to a Google Cloud and Azure and says, I want to run my network on you, that's a pull. That has to be delivered in some way. Is it going to be, 5% of the infrastructure is upgraded? Maybe. Is it going to be some swap outs? Maybe. So again, I'm not sure it's the place of OCP to recommend a model, because from what we've seen, everyone is doing something slightly different because they're starting from a place that's slightly different.
Okay. All right. Thanks.
Okay,
Thank you, Anand.